Welcome to Chapter 7, Lesson 7.1. We're going to be doing a whole chapter on radical equations. What that means is like square roots, cube roots, that kind of thing. So this lesson, we're going to be going just through some definitions and just how to simplify some expressions before we even talk about them embedded in equations. So the objective today is we're simplifying nth roots. The reason why we're talking about nth roots instead of square roots is we're talking about more than just one kind of root. You're probably more familiar with square roots at this point than anything, but we'll talk about some cube roots and even some fourth roots in this lesson. So nth root definition. For any real numbers a and b and any positive integer n, if a raised to the power of n equals b, then a is an nth root of b. So what that means is it goes both ways. The n is how many times you multiply a by itself to get b, right? So for instance, if you say that 2 cubed is equal to 8, which is true, right? Then 2 is a cube root of 8. So these statements are interchangeable. They go back and forth. I don't know, if you say 5 squared equals 25, which is true. 5 is a square root of 25. Okay, so that's what that definition is talking about in context. So what we're going to do here is find the roots of these numbers, cube roots. So it's what multiplies by itself 3 times. That's what this cube root stands for. So what multiplied by itself 3 times would equal negative 125, and the answer is negative 5. All right, cube roots can be negative because you multiply a negative number by itself an odd amount of times, in this case 3 times, you will get a negative, so that works. This also does work with decimals. The cube root of 27 thousandths is 3 tenths. 3 tenths multiplied by itself 3 times is going to equal 27 thousandths. You can also think about this in terms of fractions. The fraction that you multiply by itself 3 times to get 1/64th is 1/4. Now let's talk about fourth roots. It's just simply how many times, or what number multiplied by itself 4 times would equal this number. So in this case, it's 5. 5 times itself 4 times would equal 625. For some reason, I can't scroll down, but that's okay. Maybe I do it this way. Sorry about that. For this one, the fourth root of negative 16 10,000ths is actually undefined. And the reason why it's undefined and it does not exist is because you can't take an even root of a negative number. There is no number multiplied by itself 4 times that would get you any negative, let alone this negative. All right, because 4 negatives multiplied together would be positive, 4 positives multiplied together would be positive, and there's nothing else that exists. So it would actually be imaginary, if you want to think about it that way. Fractions work. So the fourth root of 81 over 625. Essentially, you just think about it, and I should have mentioned this over here with that fraction, but it's you take the fourth root of each part of the fraction separately. The fourth root of 81 is 3, and the fourth root of 625 is 5. So the fourth root of 81 over 625 is 3/5. Okay. All right, some definitions here. In a generic radical, the number up here is the index. That's telling you how many times you're breaking down the number on the inside. The number on the inside is considered the radicand. The whole thing together would be considered the radical. Right? When a number has 2 real roots, the positive root is called the principal root.